I'll discuss previous year's problems of CSIR-NET that are involving reactive intermediate carbene. And if you have prior knowledge related to carbene, then you will be able to understand all these problems easily, and for that you can check all the videos for which the playlist link is given in the description box. The first problem is the structure of the reactive intermediate generated by reaction of chloroform and KH. Now as this video is carbene related, so obviously the reactive intermediate is carbene. Now look at the options. These two are singlet, but these two are triplet. Now this combination of reagent, first there is production of C minus and Cl3 carbanion, and there will be removal of chlorine with its electron pair. So as a result CCl2 will be generated. Though I have discussed this in my video, but you can also read Clayden book, the chapter which is related to radical. There it is beautifully explained. Now this will be singlet. So these two we can already cancel. Now among these two, which one will be correct? In this case the angle is 180 degree. In this case it is not so. Okay. So this will be cancelled because when it is singlet, two types of angles are not possible. Only one angle is possible, which is this one. When it is triplet, then you can get two types of angle depending on the hybridization sp2 or sp. But when it is singlet, it is only this one is possible. So that is why option 2 is the correct option. Next problem, major product formed. Now here we have this diazo compound, and in presence of CF3CO2H, this portion, that is N2, will be removed and there will be generation of carbene. CH2, C double bond O, and then there is carbene like this. Now we have OMA group here, and as this carbene, it is electron deficient, it is electrophilic, and this part is nucleophilic. So there will be electron donation from this part, and there will be formation of a 6-membered ring. 1, 2, 3, 4, 5. So here we will have, I have missed one carbon. Okay, it is CH2, and then there is this carbonyl. So it will be 1, 2, 3, 4, 5 and 6. So 6-membered ring will be generated. Aromaticity is lost. OMe, oxygen is positively charged. And then there is this newly generated 6-membered ring. Now if you look at the options, here aromaticity is not maintained. Fine. And also there is a formation of 6-membered ring. Now aromaticity is maintained only in these two, but these two are not correct, because the newly generated 6-membered ring that you are seeing, that you can find only option 3 and 4, and also in not option 4. From the position it is clear. Now in 3, as you can see, this part is completely like this, and this MEO plus, basically here water is not mentioned clearly, but you have to consider it as if it is aqueous acid. So that is why when H2O, it will attack at this methyl, then methyl will be removed, and as a result finally you will be getting this C double bond O. So now you can find similarity with the structure that is given in option 3. Okay, so this will be the correct option. Now this problem, which is December 2014, previous one is 19. So from 19 I have jumped from this 14 because the problem is same, just like before. The problem you are saying in the previous one. Only difference is here the stereochemistry is mentioned. Otherwise there is no such difference. Fine. So here also this that is carbene will be generated at this carbon, and lone pair will be donated. From this carbon there will be a newly generated 6-membered ring. Now that you can find in which case? You can find it in this case, because I will not consider this one, because MEO will not be present finally. It will be attacked by water, and finally aromaticity will be lost, and it will be C double bond O. Okay, so correct structure is this one. This, remember these two positions, there are CC double bond. This is the newly generated 6-membered ring, and we don't have to bother about the stereochemistry because that is not the matter of concern. Here if you follow the bonding connectivity, it is matching only with this option 2. Major product formed in the following reaction. Here we have a phenol derivative given. The first reagent combination CHCl3KOH. Now this reagent combination, obviously it will produce this carbene, right? And in the second case there is reagent H2O2NaOH. Now first, from the reagent you have to recognize the reaction. Carbene will be generated, that is fine. And your starting material, there is phenol derivative. Now this reaction is basically Reimer-Tiemann reaction. Here I have mentioned this Reimer-Tiemann reaction, that is the common mechanism. It happens in basic medium. So first this H will be removed. It is phenoxide ion. Now this CCl2, as it is electron deficient, so electron from ortho position, it may be meta also, but here ortho is shown. So from ortho position there will be nucleophilic attack towards CCl2. Next, this CCl2, it will capture this hydrogen. It is as if intramolecular proton transfer, and finally this 2HO minus, it will attack the CHCl2. I am not going into the details. Finally the CHCl2 will be converted to CHO. So this is the final product. So if we follow the same thing, in our case the final product, that should be OH, ortho position CHO, para position there is already ET. So this is the product of the first. Now you are treating it with hydrogen peroxide in basic medium. Now when you have hydrogen peroxide in basic medium, and if you have any COR group, not necessarily CHO, COR group, and this reaction is better if you have any donating group at para or ortho position. Fine. So here we have donating group OH. Fine. But important point is here this COR group, in presence of this reagent combination, it will be converted to OH. That is, loss of carbon will happen. This is the byproduct. So in our case, this CHO, that will be converted to obviously OH. One OH is already there, but CHO will also be converted to OH. And this reaction is known as Dyakin reaction. So correct option is first option. Let's move to next one. Major product A and B in the following reaction sequence. Here the first reagent Me2CuLi, we are getting A. Then it is treated with zinc copper couple CH2I2. Now this reagent is Simon-Smith reagent. Simon-Smith reaction I have also discussed. You can check the videos. So here what will happen first? We have 6-membered ring. There is CC double bond and epoxide. Now Me2CuLi, this reagent, which is basically a source of methyl minus, it will be 1,4 addition. We know whenever we have this type of, that is CC double bond, alpha beta unsaturated C double bond O, Me2Cu, it always attacks at this position. So here also the same thing, and it will attack in such a way that after the attack, the product that you are getting, methyl, if we consider stereochemistry, so double bond will be shifted here and this bond will be broken. So here this OH and Me, it will prefer trans. Now if you follow this trans for A, these two cancelled. Now among 1 and 2, this is structure of A. Now next, Simon-Smith reaction, where CC double bond cyclopropanation takes place. Now cyclopropanation will take place in such a way that the OH group, if you are considering it as if it is above the plane, as it is given in the option, and this is below the plane. So what will happen? The cyclopropanation, it will take place in such a way that the newly generated this 3-membered ring, that will be in the same side of OH. So that is why this is not correct. Here this is also above the plane, this is also above the plane, and it will be the correct option. Remember, it will just follow the same, that is OH, if it is above, it will also be above. Fine. So option 1 is the correct option. Here if it is not properly visible, I am just saying it is rhodium acetate RH2OAC whole 4. We have diazo compound. First we are getting A, then sodium cyanoborohydride, we are getting B. So this, in presence of this reagent also, there will be generation of carbene. So first structure, in this position there will be generation of carbene by removal of this diazo group. Okay. Now once it is removed, And if you see, with respect to this position, that is these two, that is for structure of A, these two are 5-member ring, and then we also have a 6-member ring at 3 and 4. Okay, so what we will do, so there will be CH insertion, and it will be in such a way so that 5-member ring is generated. So if I am numbering it 1, 2, 3, 4, 5, so 5 and 1, these two bonds will be formed, and there is CO2ET and these 3 carbon chain present. So from, as it is 5-member ring, you can cancel option 3 and 4. Now we are left with this, it is not double bond, it is basically single bond. And here we don't have to bother about stereochemistry, because in both cases you can see these two are trans, so we don't have to choose anything. Now once it is formed, that is structure of A, next we have NaCN BH3. Now this reagent is ideal for imine reduction, but as we have here carbonyl and ketocarbonyl and ester carbonyl will not be reduced, only this part will be reduced. So if only this part is reduced, then there will be OH and CO2ET as it is, and this 3-membered carbon chain, that will also be present. And again, we don't need to be concerned about the stereochemistry, because only C double bond O is reduced, that you can find only here, whatever is the stereochemistry. Okay, so OH, CO2ET, and then there is this 3 carbon chain. So option 1, selective reduction, option 1 is the correct option. The major product formed in the following reaction: CH2Cl2 MEAli. Now normally for carbene generation, either you will see CHCl3 or CHBr3 is given, but sometimes CH2Cl2 may be present in basic media. So here also there will be generation of this carbene, and once this carbene is formed, this is actually dimer Taiwan of indole. Negative here, this hydrogen will be removed because it is basic media, and first there will be, that is this CC double bond, there will be generation of this 3-member ring, methyl as it is present. Now this negative charge, if it is making a CN double bond, this CC bond will be broken, one Cl is removed. So I am numbering here 1, 2, 3, 4. So after removal of one chlorine, there will be formation of a 6-member ring, where at 1 and 2 position there is double bond, at 3 position there is a chlorine, 2-4 bond broken, 3-4 position there is a double bond. So this should be the final structure, right? And it is matching with which option? Sorry, I forgot this methyl. So it is meta position with respect to N, chlorine is inserted. So this should be the correct option. Now similar type of, though one thing I would like to mention, that here another possibility is that when there is a that is this negative charge over N, it is making a CN double bond, this 2-3 bond can also be broken, and if 2-3 bond is broken, this 5-member ring, it will be still there, and there will be CHCl2. So in this case basically what happens, finally there is conversion of CH2 to CH formal, and this 5-member ring is intact, but that product is not given here, so we don't have to bother about it. It will be this one, that is pyridine ring will be generated, and at meta position with respect to N there is chlorine. Similar type of problem which we also have December 2013. Here we have not CH2Cl2, not MEAli, but we have CHCl3 NOH. But whatever it is same type of reaction. And one new thing, here we have one extra methyl group, but ultimately what will produce? There will be a 6-member ring. Pyridine ring, and see at position this and meta position obviously just place chlorine, and these two methyl it will be there. So it is matching with which option? Also see here you have to mention the carbene, as it is CHCl3, after alpha elimination, 1H, 1Cl removed. That means CCl2. You are left with CCl2. So these two, among these two you have to choose. Now this is not correct because position of chlorine is meta. So last one is the correct option. So these two problems are similar. Again Simon-Smith reaction, which is clear from this reagent combination, zinc copper couple CH2Cl2. Now in this case we have two types of CC double bond. Now among these two types CC double bond, this one is more electron rich. So cyclopropanation will take place here. Fine. So see, first three options, this is intact. Only in last option there is cyclopropanation. This part is intact. So this should be the correct option. Next problem. Again we have this type of reagent. So see, you can understand that this reagent, it is very common. Then another reagent, that is diazo is given, carbene is generated. These two are problems based on these are very frequent. Major product formed in the following reaction. Here we have this cis-CC double bond. Now as it is cis, cyclopropanation, when it will take place, obviously this position of this cis position of CH2OH and methyl, it will not change. So without writing stereochemistry also, just write cyclopropane. Now one, it is formed. Next reagent is oxidizing reagent, which is very strong. So in this, in presence of this type of reagent, this CH2OH, that will be converted to CO2H. Primary alcohol will be converted to CO2H. Rest of the part, there is no change. Now if it is CO2H, now look at the options. CO2H and methyl, they are cis to each other. That you can find in which option? That you can find only in this option, because stereochemistry is not disturbed. These two groups, initially they are on the same side, finally also they will be on the same side. Okay, and these two are hydrogen. If I write the stereochemistry, these two are above the. So it is matching with, that is CO2H is present in option 3 also, but here it is Me and these two are trans to each other. So that is why last option will be the correct option. And also remember, this is very strong reagent. So it will, that CH2H, it will be converted to CO2H, not aldehyde. So that is why this option is not correct. Major product formed in the following reaction. Again see, this type of reagent and you have diazo. So first what you have to prepare? You have to prepare this carbene. Now once carbene is there, you have at alpha position carbonyl. So what will happen? There will be Wolff rearrangement, which I have also discussed in detail. You can check the videos. So this CC bond, it will be migrated and there will be generation of ketene. So BNO CH2, here we have 2 methyl group, and now this carbon, it will be connected with this one. So CH, then C, then double bond O. Now we have to, there will be ring formation. Fine. So when there will be ring formation, what we will do? If I attack it with water, then there will be, sorry, it's not like this. Sorry, it is not Wolff rearrangement. I have done a mistake here. Basically, another possibility is there, which is, as we have this BNO group, which you can see, and this is nucleophilic. So this will attack this electron deficient carbon. As a result, there will be formation of 1, 2, 3, 4, 5. A 5-member ring will be generated, and BNO, which is part of the ring. So O position, this is 1, then 2, 3 position we have 2 methyl group, then we have carbonyl, and at 5 position there will be negative charge. Oxygen is positive. Now this negative charge, if Bn, I am writing it, this is benzyl group. Oxygen is positive. Now this negative charge, it will capture this CH2 pH and seize O bond will be broken, oxygen will be neutral. So as a result, what we are getting? 5-member ring as it is, 2 methyl groups, CO, and at this position there is CH2PH and oxygen. So it is matching with which option? It is matching with O and CO, they are at 1 and 3 position. So it is matching with this one. Fine. So BNO, the lone pair of oxygen, that will be acting as nucleophile, it will attack the electron deficient carbon. Correct statement about the following. So in this case, this type of condition, there will be generation of carbene from this diazone. So this is carbene. Now in this case, this CC bond migration, that will take place. So when it is taking place, that is CC bond, it will be migrating here. So this is Wolff rearrangement, and we will get 5-member ring where we have this ketene. Now we have in the medium MEOH, and this MEOH, it will attack here. So what will happen? C, OH, OMe, and finally it will be ester. Sorry, it is 5-member. So it will be COOMe. Now CO2Me with 5-member ring, that you can find in option A as well as option 2. But here it is mentioned it is through carbene intermediate. Option 2 is saying that it is through nitrogen. So obviously option 2 is not correct. 3 and 4 we have already cancelled. So this should be the correct option. Fine. Major product formed in the following reaction sequence. Cis-butene 1,4-diol. First reagent is Simon-Smith reagent. Second reagent is there is some oxidizing agent. So let's draw this structure. CC double bond, and there are 2 CH2OH group. So total number of carbon 4. This is cis. So first, in presence of Simon-Smith reagent, there will be cyclopropanation, and CH2OH, there will be no change. Next, we are using some oxidizing reagent. So oxidation will take place. But I will suggest don't do the oxidation for both CH2OH when you have this type of 2 OH groups simultaneously. So what you should do, first convert one CH2OH to aldehyde and another CH2OH as it is. Next, what will happen, this lone pair, it will attack here, and there will be formation of a 5-member ring, which is basically lactol, O CH2OH. Then do the next oxidation, because now this OH, secondary alcohol, that will be converted to ketone. So it is matching with which option? It is matching with these two. But see, here stereochemistry, that will be not disturbed. So it is always 2 hydrogen on the same side. So these 2 hydrogen, they are on the same side. Now let me draw it in the final structure. So if it is so, then find option A should be the correct option. H nu aqueous DHF. So here this position, there will be generation of carbene. We have alpha carbonyl. So there will be shifting of this CC bond and ketene will be generated. This is Wolff double bond. Fine. So at this position, now we will have now aqueous DHF. That means if we attack it with H2, remember we have also done the same thing with MEOH previously, that is attack to ketene, and in that case CO2Me is produced, but now it will be production of carboxylic acid. So now we will have CO2H at this position. Now this is beta keto acid. With respect to carbonyl, this is alpha position, beta position. Beta keto acid are very good for decarboxylation. Heat sign is given. So decarboxylation will take place, and finally this CO2H will be removed and it will be remain. So it is matching with option B. Again we have diazo compound, and there will be generation of, at this position, generation of carbene. Now this CC bond, it will migrate. So if it is migrating here, there will be ketene generation. I'm just ignoring the methyl. It doesn't matter. If you do not consider, it is okay. So after generation of this ketene, this carbon and this carbon, it will be connected, and this CC bond will be broken. Now there is presence of methanol. So same type of reaction, we have already done it. So what will be produced? There will be CH2CO2Me. So CH2CO2Me, that we can find in option 1 and 2, because these two are not matching. This is COCH2Me, it is not ester. Now this stereochemistry of methyl, actually it will not be disturbed, it will remain intact. So that is why among these two, option 1 and 2, you have to choose first option, because it will remain intact. Probably this is the last question. And the reagent A required in, and the major product B. So in the first reaction, both starting material, product given, you just have to recognize A. Now look at what are the given. CH2Br2 and potassium tertiary butoxide. This is common base, fine. Now CH2Br2, option 1, 2, CHBr3, option 3, 4. So obviously this is better. So 1 and 2 we can cancel. Now once this is formed in presence of Ag plus ion, Br will be removed, and there will be generation of carbocation, like this. Okay. Now if this CC bond is broken, now there will be formation of 6-member ring. So if I am numbering it, 1, 2, 3, 4, 5, 6, 2 6 bond broken, and at 1 and 2 position there is a double bond, 4, 5, 6, and at 6 position there will be positive charge. 1 position there is bromine. Now there is in the medium water, so water will attack here. So finally what we are getting, 6-member ring, CC double bond Br, and just beside Br there is OH. So we are left with option 3 and 4, but it is matching with this option. Okay, here the position, these two positions are 1, 3, which is not correct. So option 3 is the correct option. So that's all I have for you in this video. I will come with some more problems on different topics. So thank you for listening.